If you were amazed by the latest images from the James Webb Space Telescope, what you're about to discover takes things to an entirely different level. A new observatory has quietly begun transforming our view of the cosmos, delivering images so vast, so detailed, and so revealing that even experienced astronomers admit they exceeded expectations. The Euclid Space Telescope has released its first extraordinary observations, and they are far more than beautiful pictures of distant galaxies. Hidden within these images are enormous cosmic structures, invisible forces shaping the universe, and clues that challenge some of our deepest assumptions about how the cosmos works. Today, we'll explore what Euclid has captured, why scientists consider these images a major breakthrough, and why they become even more astonishing once you understand what you're actually looking at. Stay until the end, because these first observations are only the beginning of a mission that could completely reshape modern cosmology. Unlike most space telescopes, Euclid was never designed to focus on a single galaxy or produce dramatic close-up images of colorful nebulae. Its purpose is much more ambitious. Launched by the European Space Agency in July 2023 and operating around the Sun-Earth L2 point, roughly 1.5 million kilometers from Earth, Euclid was built to create the largest and most detailed map of the universe ever attempted. Its powerful wide-field instruments allow it to observe enormous sections of the sky in a single exposure while still capturing remarkable detail. Instead of examining one object at a time, Euclid studies millions of galaxies together, revealing how they connect across unimaginable distances. What makes this mission truly remarkable is that Euclid is not simply observing visible light. By measuring tiny distortions in the shapes of distant galaxies caused by gravitational lensing, it can trace the hidden influence of dark matter. Rather than photographing only what we can see, Euclid is helping scientists map the invisible framework that holds the universe together. When the telescope delivered its first wide-field mosaic of the southern sky, researchers immediately realized they were looking at something extraordinary. In only a short observing period, Euclid combined more than 260 individual exposures into a breathtaking panorama covering an area of sky hundreds of times larger than the full moon. The completed mosaic contains millions of stars and galaxies, yet it represents only about 1% of the survey Euclid plans to complete during its mission. That realization alone is astonishing. What we're seeing today is only a tiny fragment of an enormous cosmic map that will eventually stretch across much of the observable universe. Scientists can zoom from gigantic clusters spanning millions of light years all the way down to individual galaxies without sacrificing clarity. This isn't simply another beautiful astronomical image. It is the first glimpse of what will become humanity's most comprehensive three-dimensional map of the cosmos. Among Euclid's earliest and most fascinating observations is the Perseus cluster, located roughly 240 million light-years from Earth. The image reveals more than 1,000 known galaxies while also capturing over 100,000 much more distant galaxies scattered throughout the background. As researchers analyzed the data, they uncovered something unexpected. More than 600 previously unknown dwarf galaxies emerged from the observations, objects so faint that earlier telescopes had completely missed them. Although these galaxies are relatively small, they are incredibly important. Their motions and shapes are strongly influenced by surrounding dark matter, making them valuable indicators of where this invisible material is concentrated. The discovery suggests that dark matter may be distributed in far more intricate ways than astronomers previously believed. Rather than being a minor ingredient of the universe, it appears to provide the hidden framework around which visible galaxies are assembled. Euclid is also revealing entirely new details inside nearby galaxies. In systems such as NGC 6822, the telescope identified ancient, low metallicity stars that preserve conditions similar to those found in the early universe. These stellar populations provide astronomers with a rare opportunity to study how galaxies evolved billions of years ago. In globular clusters like NGC 6397, Euclid resolved extremely faint stars that had remained hidden in the glare of brighter neighbors. Each newly detected star helps scientists reconstruct the history of our own Milky Way with greater precision. Even famous regions like the Horsehead Nebula continue to surprise researchers. Euclid's sensitive instruments detected evidence for isolated Jupiter mass objects and possible rogue planets drifting through space without parent stars. These lonely worlds may be far more common than anyone previously imagined, suggesting that planetary systems are only one part of a much larger cosmic story. Instead of revealing a quiet and orderly universe, Euclid is uncovering a dynamic cosmos filled with hidden structures, invisible matter, and countless discoveries waiting just beyond the limits of previous observations. As astronomers continued processing Euclid's observations, an unmistakable pattern emerged across the universe. Galaxies were not randomly scattered through space as isolated islands. Instead, they traced enormous filaments stretching across hundreds of millions of light years, weaving together an immense network known as the cosmic web. These colossal strands intersect at massive junctions where galaxy clusters gather, while enormous voids separate the dense regions. Euclid's unprecedented clarity allows scientists to visualize this architecture with remarkable precision, revealing a universe connected by structures that were once only predicted by theoretical models. The most striking realization is that these filaments are shaped largely by dark matter. Although invisible, its gravitational influence directs where galaxies form, how they cluster together, and how matter flows across the cosmos. Every galaxy, including our own Milky Way, occupies a position within this hidden framework. One of Euclid's greatest scientific achievements is its extraordinary ability to measure gravitational lensing. As light from distant galaxies travels across the universe, it passes through regions filled with massive concentrations of matter. Gravity bends that light ever so slightly, subtly stretching and distorting the appearance of background galaxies. The distortions are incredibly small, far too delicate to notice in ordinary observations. Yet Euclid can measure these tiny changes across billions of galaxies, allowing astronomers to reconstruct the distribution of matter that cannot be seen directly. The resulting maps reveal enormous concentrations of dark matter spanning millions of light years. These invisible structures outweigh all the stars, planets, gas, and dust that telescopes can observe, yet they emit no light of their own. They remain hidden except through their gravitational influence.